as promised, I'm continuing almost immediately into hand states. So, how are we going to handle this? Well, what we can probably do first is set up the inputs. So, if we go to project settings, under input, let's put an action mapping in here. Let's put a couple. Let's go swap hand state left, and I guess we'll make it swap hand state right. And here we're going to have a look in here, and we can just type Hydra, and let's make that for the left hand. I'm looking at the buttons. Left hand, I'm going to make it button 2. I'll use the ones on the inside. Hydra left B2, and then here we'll go Hydra right B1, button 1. Hydra right, button 1. Alright, that should be nice and happy. So in our Hydra character, let's go and get those inputs. So swap hand state left, swap hand state right. And the first thing I tend to do with this stuff is throw a print string in there. So go print, and we'll chuck that there. We'll go left, swap. I don't care about the spelling. This is really just to make it go ding. And we'll go right, swap. I'm good at words. Save that. I'm trying to do this too quickly. Compile, save, click, bang, boo, 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 boo. Right swap, left swap. Cool, beautiful. They're working. So frag those off. Now, I have. Alright, so what do we want to do? The next thing I think we want to do is create an enumerator. So under blueprints, we'll create an enumeration. And we'll call this hand states. What this is going to let us do if we open it up, it doesn't seem like it does a lot, but this is a way for us to track our states. So we can add new entries to it. So we'll set our base one to grab. We'll set the next one to point. Let's set the third one to weapon. And we'll set the fourth one to, I don't know, tool or something like that. Whatever we want to have happen. So these are going to be the names of the different states that we can cycle through with the hand. We could add 1 million entries to this, but for now we're just going to leave it at 4. Back in our Hydra character test, let's grab this one up a little bit. We're going to add a couple of variables. The first one we're going to put is left hand state, and we will make that variable type of a hand state. Hand states. So under enum, you'll see hand states. And that's cool. And then we'll duplicate that one. Let me duplicate you. Duplicate. Right hand state. Okay. So we're going to drag this out and set that. I'm going to set that as well. Now I'm going to refer back to my other template project, because I had normally cycling through a loop of things in an array is pretty straightforward, but I found with the enum, because you have to convert the bytes to an integer and all that kind of stuff. So let's do it for the right hand first. So we'll get the right hand state and we'll check that, and then we're going to set the right hand state. We'll use plus and choose byte plus byte. So rather than being stored as an integer of an index in an enum, they call them a byte. I know there's a really good reason for that, but I don't know. I can't recall it right now. So right hand state plus 1 means that this enumerator, which if I compile, is currently set to grab, will switch to point. Right? So we're going to add 1 to the index, the same way that we'd cycle through an array of things. Now, if that is greater, if we reach the end of these hand states, if we get to tool, we want to cycle back around to grab. So what I found is that we can go number entries state, get number of entries in hand states. If we had something that was an array, we'd be able to drag off of that and get the length of the array and use that in this way. But with the bytes in the enum, we have to do it by getting the number of states. And I'm pretty sure that I had to specifically convert this to an integer. Integer? No, was it? Vector to int. ToString int, no. Integer, 2 int, 2 byte. converts an integer to a get into option. Maybe I didn't. Okay, so we want to know if the right-hand state plus 1, so the one that we would be switching to when we hit this button, when we call this action, would be greater than or equal to the number of entries in hand states. So if the byte would be greater than or equal to that other one, so go here, convert integer to byte. Yeah, that's right. Sorry, I was wrong there. This is providing us an integer. We have to convert it to a byte at this point. So we'll drag off of the boolean here, branch it, and in fact, this stuff probably wants to be back here because it's doing it all there. If we press this button, we want to check that state. Now, if the current right-hand state plus 1 would push us over the edge of the number of hand states that we have, we just want to set it to grab. We want to cycle back around to the start. And that means that right-hand state, the next time it checks it, will be going to point after grab and all that good stuff. If not, then we want to set it to right-hand state plus 1. And so it'll cycle through and do its good stuff. And that's all well and good. And that's pretty much all we need to do for that one. Let's throw a print in here. And let's drag off and make an append on this, and we'll go right hand state is, and we'll get that, and that's right. We have to do enum to string. That's a really specific one. If you just drag off here, it's going to give you a whole bunch of information you don't necessarily want. What you actually want is the name of the state, whereas it's going to give you the enumerator index for it, and then maybe its state in there. But I'm gonna use this this enum to string little node there. Actually, we don't want to do that. We want to get the right hand state no matter what it is. If we drag off there, it's possibly going to give us some dramas. So we'll get that, and we'll go string enum to string. Plug that in there, and then we'll have both of these plug around to it. So let's quickly do that for the other one as well. Now, actually, what I will do is grab everything here. This is a neat trick that you can do now. Oh my goodness, it's awesome. Copy and paste that thing, plug in the left, and... But hey, I hear you say, this is all set up for the right hand. Yes? Yes, you are correct. However, what I can do is drag over and change node to read left-hand state. That's going to be the same no matter what. Drag this one over here. Change node to right left-hand state. Change node to right left-hand state. And then change node to read left-hand state. So, yeah, that's pretty much how easy it is to set up both of the hands. I'm assuming that it's going to... Oh, and I'll change this text here. That's the one thing I can't do automatically. Left-hand state. So we'll save that. And then back in here, by rights, if you look up in the top corner, right-hand state is now point, weapon, tool, grab, point, weapon, tool, grab, point, weapon, tool, grab, point, weapon, tool, grab, point, weapon, tool, da 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 da. So I'm switching between those different states. Now, I hear you ask, Craig, why the hell would that be useful? Well, what is useful is if we create a function that is called update hand state, maybe, or like, yeah, let's call it that. And the input that we're going to take is going to be the hand state, and we'll make that an enum of, well, we'll just type state in here, hand state. And I think we might want to reference to the controller as well. So go hand controller, and we'll make that a controller motion controller component. We'll make that a reference. And hey, why the hell not? We'll go hand static mesh, and we'll make that a static mesh component. And then we'll also add a hand skeletal mesh. And we'll make it a skeletal mesh component. Alright, so I'm setting these up so that I'd be able to pass in anything that I might want to have. Right now I'm using static meshes for the hands, but the fact is you want to have some skeleton there if you want to be able to do proper hands. So in update hand state, we will start by, well actually let's call it first. So after our print string, which we'll be able to circumvent at a certain point, we're going to drag in update hand state. Alright, so we'll just plug it in here for now after our print string. That's fine. So we can still have an idea of what it's doing. What we want to do is look at the hand that we're using and then plug the appropriate hand state in there. So that means that when we call this function, it's going to poll this variable of left hand state. And then we can grab the left hand controller, drag it in there as a reference, plug that into the hand controller. So we've got that if we need it. Like if we need to do stuff like work out how fast it's going or what its angle is and all of that kind of stuff, it can be easier for us to pipe that in here and kind of handle everything else in an agnostic way. I know I keep using that word agnostic, but a kind of impartial way, irrespective of which hand it's doing it to. So we'll make this functionality work for either of the hands at any point, but when we call that function, we tell it which hand we want it to operate on. So that makes it a little bit more flexible. And the left hand has this static mesh, no skeletal mesh right now. That's all well and good. So again, I'll copy this stuff and put it up on the right hand one as well. I know my blueprints are messy. Don't tell me my blueprints are messy. I know. I'm trying to do this quick. Hang on. We'll drag that to be right hand state. Sorry, change it to read that one. And then we'll get a reference to the right hand, put that into hand controller there, and for static mesh, we'll go for the right hand mesh. Keep that there. So now we should be able to have this stuff work. Now, because we're piping in this enumerator for this right hand and left hand, and it's agnostic at this point, we can drag off of an enumerator and have it do a switch on hand states. So depending on which state is being passed into this, it's going to do different things. So gosh, what can we do? Let's create a material, let's call it dinmat, and we'll go here, we'll make it, give it this one, plug that in there, convert that to a parameter, and call it color, and we'll spell that the correct English way. And by default, we'll make it, I don't know, pinkish. That's fine. Alright, that's probably all we really need to do. So, in our construction script, actually, no, let's create a new function. We'll call it make dynamic materials. This will be a little side hatch bit of business. Alright, so let's get the static mesh here. Let's actually rename that left hand mesh. We'll drag off and create a dynamic material instance for left hand mesh, and the source material will be dinmat. We'll create it, and then we'll actually return that value, promote it to a variable so we can grab it later and call it left hand mat. And then let's do the same thing again, except this time it's going to be the right hand mesh in there. Plug that one there, right hand mesh. We want to create the same one, and we'll promote that to a different variable. Call it right hand mat. Alright, sniggly boosh, plug that in there, bam. So if we compile and save now and we run, maybe I shouldn't be doing that in there. Element index 0, right hand mat, material instance. Oh, what mesh am I using for them? They got two. Okay. Alright. Maybe I shouldn't be doing this. This is just going to confuse things. Alright, but that's fine. In the construction script, Oh, what did I do that make? Oh, because I'm not calling that function. Kadosh! Make dynamic materials. I should be able to do that in the construction script. Okay, great. So I'll actually cheekily go back here and reset that to be none for those ones because I want to see it actually properly working. Compile and save, and now, yep, they're all good. Yep, cool, sweet, awesome. So I'm creating my material instances, and then I can clear that off. So in update hand state, if we grab, oh, actually, all right, okay. Material instance dynamic reference, and let's call it hand mat. This is very much the dirty way to do this, but I'm trying to get this done really quickly now. For the right hand, it's the right hand material. Honestly, we should be able to get this from the mesh that we bring in, but I'm doing it kind of the stanky way. Hand mat, left hand mat, that's fine. Okay, yeah. All right, so we're here now. We're here. Let's drag off from the hand material and set vector parameter value. Right? And this is essentially saying what color am I going to make this thing be. So the parameter name we need to get from the dynamic material, which is color. And even though I know it's spelled correctly, I'm still going to copy and paste it into parameter name there. So whichever material is passed through is going to have its color set to something. So let's do this. Copy, paste. We've got 4 states. Yes. So point, weapon, and tool. Let's create a couple more variables. I could probably make these local. Maybe? Yeah, probably could. 1, 2, let's make that one a color, linear color. Linear color. And its default is going to be blue. Okay. So blueprint is not a material, therefore target must have a connection here, or whatever. Got to plug those in so it knows which material to be doing it to. Okay, save. So I'll call this one grab color and duplicate it. Make another one called point color. Duplicate that, make another one called weapon color. Duplicate it again, and make this one color. Alright, so grab color is going to be the one that we use there. Point color is going to be the one that we use there. Weapon color goes in there, and tool color will get back here node, go in there. So grab color is cool. Point color, let's make that red. No, let's make it purple. Weapon color, make that green as bro. No, make it red. And tool color, will make that green. Sniggity bam. Alright, so when this function is called, it's going to take an input for a hand state and then switch based upon whatever state is sent in. Based upon that, it's going to set the color value for the material that we created in the other make dynamic materials and assigned to the left and right hands. Set them to use these various colors, and that's cool. So when we switch the state, we go through to the hand, and we update its material. And so this actual whole branch here could very much be collapsed down into a function and just take an input for which hand state, and maybe these ones as well. So, you know, you could make this a lot neater and a lot simpler as well, which is kind of what you do want to do, I think. Jump back in here. Alright. So, point, weapon, tool, grab, 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 point, weapon, tool. There was something interesting happening there when I first started it though. So the dynamic material, I'm going to set those to be black to start with, so that when it gets... Alright, this is an interesting example, alright? So we'll save this material. We're doing pretty much everything correctly. The only difference is, when I hit play, you see they're both using the black material. So even though my hand state is going to be in grab, because that's the default for the enumerator, it's not necessarily using the grab. It hasn't updated the grab thing. Whereas if I hit point, it goes to the pink one, and everything after that works perfectly fine. So what that means is that I need to initialize this. So where I've got my update hand state, I can... What's a good way for me to do this? I think I'm just going to do this the filthy, filthy, filthy way. Oh, this is very, very much the stank. This is stanky. I could drag off of one of these and go update hand state and call that function, and then copy all of these and plug them all in. Actually, that's what I definitely should do. Or I can just plug it straight in there, because I've already got them set up there. So that's that's the cheaty way. And then I'll have it update the other hand state, and that's connected to begin play. So when the game starts, it's not going to bother doing all of this stuff. It's not going to bother evaluating all of the states and everything. It's just going to take whatever the default is, which is grab, and do this and set the material and update it when the game initializes. Boom. And they're both blue. Boom. Point. Point. Weapon. Weapon. Tool. Tool. Alright. Cool. So, that about covers it. I think that, you know, if you can make a system like this work where the functionality is where you update it, and this could do stuff like, in my example, I had to do things like set like what actions were taken when the player would then hit one of the buttons or the trigger or something like that. So playing different animations and all of that kind of stuff. But I abstracted the notion of which hand it was applied to. I made it all completely agnostic. So you write it once and it works for both hands, or it could work for 500 hands if you had them. Assuming that they each had their own separate left-hand state, right-hand state, you know, that kind of stuff. But the fact that you can plug them in at this point, you can specify it just when you call this function, and then all of the logic to handle what that is drawing from what's been passed in, makes it a lot more efficient. And using a state like this for your hands can work really well. And don't forget that when you come off of something like this, even though I'm setting the vector parameter value, I could just as easily have, you know, a function called fire weapon, and we'll have it go print string, we'll go pew pew, compile and save that, and in update hand state we can have it, actually no, yeah, alright, yeah, alright, okay, so if it's on weapon, let's call that function to fire the weapon, alright? Now, obviously this is not how you would do it, but I'm trying to use this to show you that you can call other functions from after these switch statements. So you don't necessarily have to have a gigantic, crazy nest of blueprints that run all over the place off of one of these switches. You can try and keep it really compact and have all the stuff to handle firing your weapon existing in a sub-function, and just try and keep your main ones clean so you can see what's actually going on. So that's it. Whoa, 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 whoa. Pew. And if I go boo, pew, pew. Pew, pew. So they all go pew, pew, pew when you get to the weapon. Pew, pew, pew. So, you would probably set a boolean for whether or not the weapon was equipped, and then in a separate function, you would have, when the trigger axis was pulled, have a switch statement after that. Like a function that you call when the triggers get pulled that have all the hand state, the hand mesh, the skeleton mesh, like all the other stuff that you'd need that we had in this one here. So hand state, controller, static mesh, skeleton mesh, hand mesh, blah, blah, blah. And within that function you would pipe into a switch that would go, alright, is it a weapon, is it a tool? If it's a weapon, when the trigger gets pulled, then spawn a projectile and shoot at something. If it's a tool, then play an animation or repair something within distance, whatever the case may be. So yeah, that's cool. Pew, 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 pew. And that, ladies and gentlemen, is how you get the motion control set up, or at least as best as I can. Calibration stuff, you know, you flame away, because I have not gotten around to doing it yet, but I will soon. So thanks very much for watching. I hope that this has helped.